Describing Communication Technologies by Alexis Reeves. What is speech recognition technology? Speech recognition systems work in conjunction with word processing programs to enable the user to produce written text on a computer through speech. The user dictates into a head-mounted microphone, and the speech recognition system, hardware and software, converts the spoken word into electronic text displayed on the computer monitor. Here's an example. This is how you use speech recognition technology, period. What is dyslexia? Dyslexia is a specific learning disability. It is neurobiological, thought to be from a deficit in the phonological component of language. It's characterized by difficulties with accurate and/or fluent word recognition and poor spelling and decoding abilities. Secondary consequences may include problems in reading comprehension and reduced reading experience that can impede vocabulary growth and background knowledge. So how does this technology help? It comes under the umbrella of assistive technologies. It acts as a step further from human transcribers once used in the classroom to support those with dyslexia and other reading and writing difficulties to perform written exams, essays, and other written tasks. Other prior aids used for those with reading and writing difficulties were the use of a variable speed tape recorder to record lectures or assignments, listening to books on tape, or utilizing talking calculators or handheld spell checkers. With the growth of computer and device use in homes and schools over the past 25 years, it's become easier to implement as an aid for dyslexics. It's also been shown to outperform human transcribers as a means of compensating for students' written language difficulties, thought to be because of social interferences such as embarrassment and inability to read transcribers' written work. History of speech recognition and speech-to-text technologies. Timeline. In 1952, the Audrey system by Bell Laboratories was invented. It was a large, expensive machine that recognized spoken numbers 1 through 9. It was used for helping toll operators to take more calls. What you just saw was the shoebox, invented by IBM in 1962. It recognized numbers in simple math terms, 16 words in total. IBM engineers programmed the machines to use sound and pitch of each phoneme as a clue to determine what word was being said. Then the system would try to match the sound as closely as it could to the pre-programmed tonal information it had. At the same time, Japanese labs were developing vowel and phoneme recognizers and the first speech segmenter. What you just saw is how Harpy works. Harpy was invented by the U.S. Department of Defense in the 70s. It recognized sentences from a vocabulary of 1,011 words. And by the end of the 70s, speech recognition systems were beginning to be used everywhere. What you just saw was the Julie doll. It came out in 1987, and it used speech chips to respond to a speaker and could distinguish between speakers' voices. IBM also released an experimental speech-to-text tool called Tangora during this era. It could recognize and type 20,000 words in English. In the 90s, scientists created more natural language processing software using algorithms. Dragon released Dragon Dictate, the first commercial speech recognition software. It cost $9,000 at the time. Later on in the 90s, they released a more advanced version, Dragon Naturally Speaking. In 2007, Google released Google Voice Search, bringing this technology to the forefront. It also recycled the speech data and used it for training material for machine learning. In 2010, recurrent neural networks and long short term memory led to automatic speech recognition systems, ASR, the form of speech recognition technology that is most popular today, such as Siri. This technology is now able to discriminate amongst a variety of words, languages, and accents. Pros and cons. This technology has been shown to improve reading and writing for students from young learners through to adult learners, with the most gains being shown in younger learners. Better grade point averages, larger vocabularies, higher essay and test scores, and higher retention rates in post secondary institutions have been shown in older students as well. Students aged 9 through 18 were shown to have significantly higher scores over a contrast group on measures of word recognition, spelling, reading comprehension, and phonological processing in another study done by Higgins and Rushkind. This technology, using speech to text capabilities, allows for multimodal design to appeal to auditory, visual, and kinesthetic learners by use of voice, visual representations of the words spoken, and the use of selecting the correct words using the computer mouse and holding and using a microphone. The bimodal affordance of auditory visual components have shown gains in students' use of phonological decoding. Speech to text recognition technology helps improve basic literacy skills by helping identify errors in more than one way. Students can also replay their written work created through the software auditorily. This is afforded through more modern versions of the software. Students can view their work while listening to it simultaneously, allowing for two modes of recognition to help error correct, either independently or with the help of a teacher and support. This technology allows for additional opportunities for greater phonological awareness, increased phoneme grapheme correspondence and phonological processing, greater understanding of phonological segments and alphabetic codes, resulting in improved word recognition and spelling, increased reading comprehension and phonological elision and non-word reading, helps with discriminating between similar sounding and looking words, and enhanced use of mature and complex vocabulary. It also aids poor verbal short-term memory by allowing instant transcribing of thoughts and verbal utterances onto a visual aid to free up short-term memory stores. Use of this technology can be linked to increased interest and motivation in reading and writing due to self-paced, independent design mechanisms, along with the opportunities for exploration and play. It also increases motivation to use larger words in writing assignments by reducing fear and embarrassment of spelling difficulties. The use of this technology allows for implicit phonological instruction and training embedded in an authentic and realistic academic context to help with reading and writing for students. It has been shown to have minimal training time required for use, therefore it can reduce teachers' time used for training in other more hands-on methods, and students can use it independently once instructions are mastered. It can also reduce extra staffing requirements. Cons. Speech recognition is not as accurate with children's voices, which can lead to discouragement. Sometimes speech to text doesn't understand user intent or different accents. Some students may read a word incorrectly, making it difficult to predict the correct words and spellings produced using the technology. Some students speak about other things unrelated to reading and writing tasks, and therefore incorrect words or sentences can be generated. It's proved difficult to implement in schools. A quiet environment is required since children speak aloud when using the equipment, which may interrupt other classroom activities. Students may still require monitoring and supervision depending on their abilities, which may require further staffing. And educators need to spend time to alter the curriculum to include this technology in their approach to promoting emergent literacy. Conclusion: as any new technology that begins to gain momentum in our world today, we must take the time to study and understand its benefits as well as its potential flaws. In doing so, we may be able to apply it to the groups of people who need it most in our society and in the most beneficial ways. Using assistive technologies such as speech recognition technology can help level the playing field and create more equal opportunities for children with disabilities such as dyslexia. Speech recognition technology has come a long way from its bulky, expensive, and limited predecessors, and has shifted in its intended uses as well. From being used to benefit telephone operators in the 1950s to being used to benefit dyslexic students and ease our everyday lives in the 21st century. This technology has also begun to be proven successful in other areas of education as well, such as to support collaborative learning activities with multiple participants speaking simultaneously, such as group discussions or students' oral presentations. It's also been shown recently to bridge culture gaps and enhance cultural understandings when combined with translation systems. Finally, this technology has proven it has multiple uses that can be studied more so that it can be employed to help benefit those that need it the most in our ever-evolving society. References. Thank you.